Hello everyone, welcome back to my math channel online today. So before we get into the lesson, please let me remind you about our mathematics teachable, mathematics online teachable of Canada has been recognized as a free public online education to the whole world. So I hope that all students will register to our math courses online, mathcourses-online.teachable.com. And they're just a little small fee for international student and the North America student. It's open on July 3rd, so please write down the date. And I'm so excited to welcome all our adult students across the world, or college student, high school student, whoever would like to understand about the STEM subject, which is very important and have a strong push in our education across the world now, because the world has been changed to the digital learning. So I will see all of you there on July 3rd. So let me get into the lesson today. And I hope that you will enjoy our online learning together. On the board, I have 10 factorial multiply with 4 factorial divide by 8 factorial times 6 factorial at the bottom. So the topic today is about factorials, and we will see how we're going to simplify the number in factorials as well as the algebra expression. So let's see how we can do that. Let me remind you about the pattern of the factorial number. If we have a 10 factorial, we can expand them like this. So we start from 10 and we multiply with the next number going down, descendant, which is 10 times 9 times 8 times 7. So one level lower than the previous one at a time. So 10, we start from 10, we go down, times 9, times 8, times 7, times 6, times 5, times 4, times 3, times 3, times 2, and of course the last number will be times 1. However, to save the room, because any number times 1 is just 1, so I'm going to omit this 1 number here. Time with 4 factorial will be times 4, times 3, times 2, and of course times 1, but again, I'm not going to put in to save the room. Now down here, we start from 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. The next one will be 6 factorial, which is start from 6, number 6, times 5 times 4 times 3 times 2. After I expand them like this, because that's how factorial means, right? Now I'm going to cancel whatever the same on the top and the bottom. So let's look at the pattern here. I have 4 times 3 times 2. So I'm going to bracket this number. Down here, I have 4 times 3 times 2. So I'm going to bracket it. On the top, I have the number 8 times 7 times 6 times 5 times 4 times 3 times 2. So I'm going to group this in one group. down here, I have 8 times 7 times 6 times 5 times 4 times 3 times 2. So exactly what these number on the top. So we'll group it as well. So this group exactly the same like this group down here, and they all multiply together. I can cancel all of them. As well as this second group here, 4 times 3 times 2, 4 times 3 times 2, I can cancel it as well. So on the top, I have two numbers left, which is 10 times 9. And the bottom, I have two numbers, which is 6 times 5. Now, I'm going to cancel the 10 on the top with the 5 down here. And of course, 10 divided by 5 equal to left over. So now the number 9 and the number 6 down here, I'm going to divide the 9 by 3. 9 divided by 3 equal 3. And 6 divided by 3 equal 2. So now at this point, I have a 2 left over on the top and a 2 left over at the bottom. I'm going to cancel this 2 as well. So at the bottom, all the numbers are canceling out. And therefore, of course, is equal 1. On the top, all the number also cancel, and there are only number 3 left. So the answer is 3 divided by 1, which is equal 3. So once we have 10 factorial times 4 factorial divided by 8 factorial times 6 factorial, this is the answer after we canceling like this. And the purpose of this exercise is to be able to understand what factorial means and how we can simplify it without the use of the calculator. And that's the purpose of the homework, the practicing exercise. Okay, so now we're going to progress through the next question. In the next question, we have two root of bracket on the top and two root of bracket at the bottom. And these are not the number like this, right? But it's the algebra expression. So let's take a look at the first bracket. We have 2n minus 1 factorial times with n plus 1 factorial divided by 2n plus 1 factorial times with n minus 1 factorial. How are we going to approach this problem? Let me give you a hint, right? Now, first of all, you have to understand if you have 4 factorial, you can express this as 4 times 3 times 2 times 1, just like we just did it, right, on the first question. So this pattern is going down by one level. We call it descending order, right? Descending order is going down. So I'm going to put the arrow going down as a descending order. 4 times 3 times 2 times 1. Now, however, you also can reverse the arrangement, right? So you can write as 1 times 2 times 3 times 4 and just stop. And this also the same equivalent to 4 factorial, but in a different arrangement. Each level up by 1 instead of going down by 1, this is going up by 1. But the equivalent of value exactly the same, right? So that will be the expression of ascending order, going up instead of going down. However, these exactly the same. Now, why do I show you this? Because I want to look at this and explain it to you. We can explain this in either way, descending order or ascending order. It depends on the question and depends on our purpose. We want to simplify, right? So 2n minus 1 seems to be more complicated than n plus 1, so I'm going to leave this bracket alone as the same way. So just copy it to n minus 1 factorial. Now, because I want to cancel this n plus 1 with n minus 1, but they're not the same, so I cannot cancel. But I can make them look the same, so I can cancel, right? Now, I notice this is bigger than this, n plus 1 bigger than n minus 1. So I'm going to change the n plus 1 in the way that descending order, so that I can turn it into this notation, n minus 1, to be able to cancel them together. So I'm going to start with n plus 1, multiply with the next level going down, which is just n instead of n plus 1, time with the next level will be n minus 1. And of course, this is keep going until I hit 3 times 2 times 1, right? The last 3 number here. Then I don't have to put in factorial notation. But my purpose is just stop right here, hanging in the air. It means this pattern keep going. So I have to put in factorial notation. So n plus 1 factorial now become n plus 1 going down 1 level, multiply with n minus 1, stop factorial, right? Because I'm not keep going. So down here, I look at these two brackets. I'm going to keep this one exactly the same, n minus 1 factorial, so that I can cancel this one with this one. But let's look at this one here now on the left. I'm going to expand this expression, and this one bigger than this one, right? On the top, I have 2n plus 1 minus 1. At the bottom, I have 2n plus 1. So I'm going to turn this in the way of descending order again to make it look like the top one so that I can cancel. So I'm going to going down, right? So 2n plus 1, which is just 2n plus 1. Multiply with the next one will be just 2n, and the next one will be 2n minus 1 factorial. So by expand this from 1 bracket become 3 bracket like that, I lead it through this number, and now they look exactly the same. I can cancel it. As well, this one here, exactly the same down here. I'm going to cancel it. So on the top, I will left with n plus 1 times n. And at the bottom, I left with 2n plus 1 times 2n. 2n plus 1 times 2n. Now, at this point, I'm looking back again. I think I still can cancel the n on top and the n down here. So my final answer for this will be equal n plus 1 on the top, and the bottom will be 2, which is right here, times 2n plus 1. And that is the furthest I can go. But it's simplified enough, right? From the complex one with the factorial notation, now I get rid of the notation of factorial and left with just a few number. So that's how we do it. I hope you follow me. Okay, so now I'm going to go to the next number 3 question. How are we going to expand this one or cancel this? Let's take a look at it. This is a complex expression, right? More complicated than this one. How are we going to do this? I look at this is n minus 2 factorial, down here n minus 2 factorial. But be careful, right? We cannot cancel this and this. And the reason, because on the top you have a subtraction, right? Remember, this term is n factorial minus 6 times n minus 2 factorial. You cannot rip them apart and say, I'm going to cancel this one with this one. Unless they are in multiplication forms of 2 bracket or 3 bracket, then you can simplify. You can cancel. But if they have a subtraction here, you cannot do that, right? So how are we going to do with this question? I give you a hint. I am going to make them become a multiply form together so that I can cancel, right? And how I do that? So let me expand the first number n factorial here. So that start with the n. So let's do n time with one level down will be n minus 1 time with another n minus 2 factorial. And we still have minus 6, just copy it down, and n minus 2 factorial. Down here, we have n minus 3 time with n minus 2 factorial. So now, on the top now, we see we have n minus 2 factorial, n minus 2 factorial as the common factor. So we can pull the common factor out. Will be n minus 2 factorial, right? We're going to pull this 2 common factor here out, and we're going to open the bracket. We're going to put n times n minus 1 inside, and minus 6, right? Because this time this, we get back to the whole thing here, and this time this, we'll get this here, right? So that's how we pull out the common factor. Now, once they become a algebra expression with the multiplication notation, then we can cancel it, no problem. We're not get stuck anymore, right? So n minus 2 factorial, n minus 2 factorial, they are in multiplication form now, we can cancel it. So this one gone. What do we left over? Let's see. I'm going to distribute this in here. So the top will become n squared, right? N times n is n squared, minus n minus 6. That's the top. Bottom, we have n minus 3. Now let's try to factor this one and see if we can cancel again, right? So of course, I will have 2 brackets when I factor. And this we can split, become 3 times 2. So therefore, we have an n minus 3 in here. We want to take minus 3 and plus 2 to add back to minus 1 in here, right? So as long as we split this factor, become 3 times 2, and we assign this in negative 3 and plus 2, when we add these 2 numbers, we get back to the midterm, then that's how the factor works, right? So we know one number will be n minus 3 and another number will be n plus 2 from here, right? N minus 3 from here and n plus 2 from here. That's how we factor the quadratic algebra. So now at this point, obviously, cancel, cancel. And the answer for this is just n plus 2 is the final answer after we done on the simplification together. So this is the how we simplify the factorial notation. So I'm going to make this video short today. I'm going to end it right now. And the next video, I'm going to split into 2 videos instead of putting one long term. I'm going to end the video here to show you how we can simplify the factorial notation. The next video, I will show you how to solve factorial equation. So far in my math course online from YouTube, you have learned with me about exponential function, the logarithmic function, how we solve logarithmic equation. And now we get into fundamental counting principle unit with my first two video, permutation and combination. And now is the factorial notation and so factorial equation. So thank you for watching. I hope you find this video interesting enough, and see you in the next video. Stay tuned for our next solving factorial equation. Bye for now. Everyone have a nice week.